Hello everybody. In this video we are going to learn how we can run the augmented Dickey polar test as well as the Johansen test. First of all, I'm going to bring my file that is already existed in my desktop. Here we can see the file we are going to work with, then click enter. We go to data editor to make sure that we have brought our file. Here we can see the variables we will examine, and mon is our time variable. So the first step before we start running our tests is to introduce this variable as our time variable, otherwise we could not proceed. Easily we go to the result screen, then we type in set, then the variable name which is mon, then we click enter. As we see, the time variable is mon, that spans from January 1990 until December 2017. As we see here, I'm dealing with monthly data, which is delta, 1 month. Then we start running our augmented Dickey failure test. We go to statistics, we move down to time series, then we go to tests, then we choose the first option, which is augmented Dickey failure unit root test. And here we start to run this test for each variable separately. Here we choose the variable name. Actually, when I ran this test on the level, I found that the variable includes a unit root. So how we can eliminate the unit root? The best thing is to start differencing the variable. So in this case, I'm going to start with the first difference, and I choose this option since my variable contains a trend, and the number of flags, 5 flag, I will choose as a maximum. Then we click submit. Here we can see the value of the test statistics is more than the critical value, meaning that we have to reject the null hypothesis, which signifies that the variable is not stationary. Rather, we accept the alternative one, which means that the variable became stationary after including the first difference. Then we try this test for all the other variables. Let's try for the general index. Here we put the first difference because the variable is not stationary when we run it at level. Then we click submit. Here we can see the value of t statistics, or the p-value, which is less than the level of significance, meaning that we have to accept the alternative hypothesis, then rejecting the null one. Let's try for the earning per share variable. Here we add the first difference, then we click submit. Here we can see the value of test statistics is higher than its critical value. Actually, the value of t statistics seems to be a bit high. The reason for that is because we are dealing with a large data set. Let's try dividend yield share ratio, sorry. Here we put the first difference, then we click submit. Here we can see the value of test statistics. Actually, since all our variables became stationary after adding the first difference, meaning that the variables are integrated of the same order. So in this case, we have to move on to run the Johansen test to check whether there is a long-run cointegration between the examined variables. Actually, the best thing before we start running the Johansen test is to identify the number of lags. How can we identify the number of lags? We go to statistics, then to multivariate time series, then we go to var diagnostic and tests. We choose the first option, which is a pre-estimation test. Then we click enter. Here we can put the number of lag as a maximum 5 lags. Here just let us check our time variable. Our time variable is month and it's monthly. We click OK. Then we start to define the number of lags for each variable. For example, for this variable, we click submit. Here we can see many criteria through which we can rely on in order to identify the number of lags. For example, the FPE criteria, AIC criteria, HQIC criteria, and SPIC criteria. So, which one we have to choose? The rule says that lower the value is always better, and the lowest value always have a star. For example, this value has got a star, and this value has a star, and the same for other. Here we can see all the criterias agreed on the first lag. See, for example, here 1 star and here 1 star. So if we have more than 1 star, we have to choose it then because it would be better. So the number of lags for this variable is 1 lag, and we can run the test for all the variables altogether. Let's try general index, earning per share, dividend yield ratio, market to book value ratio, dividend value, traded value. Then we click submit. Here we can see the number of lags. So the number of lags would be 1 lag, but it would be fine if we tell the test the maximum number of lag is 3 to 4. It doesn't matter because the test will choose the most appropriate number of lags. After that, we move on to run the Johansen test. We go to multivariate time series, then Cointegration, rank of a vector error correction model. Then we click enter. Here we can see the maximum number of lag to be included in the test is 2 lag. It would be fine if we put it to 1 lag, since the lag selection test told us that the number of lag is 1. But it would be fine as well if we put it 2. Then we choose our variables. Our dependent variable would be market capitalization to GDP, general stock index, earning per share, dividend yield ratio, dividends amount, market to book value ratio, traded value. Then we click submit. Here we can see our result. So now the question arises here is, what does this table means? Here we can see the trace statistics, and here it's a critical value. The rule says that when the value of the trace statistics is higher than the critical value, meaning that there is a long run integration between the examined variables, meaning that the increase in the independent variable on the long run leads to an increase in the dependent variables in the same magnitude and in the same value. So after this test, since our result says that there is at least, here we can see at least one integration between the variables, then we have to move to run the VCAM test, which is vector error correction model test. Actually, here there is another way to define the number of lag. Easily we type this order var soc, then you put the name of your variable. Let's try this variable, earning per share. Then we click enter. Here it's another way to define the number of lag. Thank you for watching with me in the coming video, which I will explain in it the way of how we can run the VCAM test and the VAR test. Thank you for watching.